Okay, let's talk about these anycast RPs. So as an example, we have spine 201 and we have spine 202. And we have configured both of these resources to act as being part of this rendezvous point configuration that we call an anycast RP. And we define that as a anycast RP set. Now the interesting part here is that by virtue of these guys being configured as a set, they are going to need to communicate with one another. To the outside world, everybody is connecting to 10.1.200.200, which is the IP address of the rendezvous point. And each of these devices are indeed advertising that address. So 10.1.200.200 on loopback 200. That's how that prefix is making it into the network infrastructure, and it's being advertised into OSPF in the topology that we have currently configured. However, each of these devices have their own unique address. Remember, we created a 201 and a .202 in the same network. And these two devices have been told the identity of the other. Remember, we typed IP, PIM, anycast RP, and we used the 10.1.200.200, but then we put in the 10.1.200.201, and then did the exact same thing down here and entered 10.1.200.200.10.1.200.202. So each device knows the identity of the other anycast RP set peers. This is a cluster. So this is a RP, or rendezvous point cluster. And what we're going to find here is as a direct result of that in the configuration. I'm looking on the topology. So in my lab, Leaf 101 is actually using spine 201 as the rendezvous point. I mean, they're both RPs. But this device actually registered with this rendezvous point specifically. And as we said, this device sent the register stop. So this is the register stop. And this was the PIM register. And interestingly enough, the IP PIM join was actually sent to and processed by spine 202. Now, that means that for the purposes of this particular session, based on this particular 5-tuple, this spine is acting as the rendezvous point. If I were to bring up 102 and do it, it would probably be the reverse, which is you're seeing here as a direct result of this process. I'm basically administratively load balancing between my different rendezvous points from the perspective of the hashing computation. Because remember, we're going to hash the 5-tuple. However, keep in mind that spine 201 knows the identity of the other devices that are in the cluster. So what it's going to do is it's actually going to pick a path. I don't know which path it's going to pick. Didn't check before I did the walkthrough. But keep in mind I've got the other spine out here, or the other leaf out here. So let's go 102. Based on the hashing computation, what's going to end up happening is that 201 is actually going to send information to all of the other cluster members, and that traffic, since my spines are not directly connected to one another, is going to actually have to traverse my leaves. Remember, we're dual connected, so 201 is connected to 101 and 102. 202 is connected to 101 and 102, but 201 and 202 are not connected to each other, and leaf 101 and leaf 102 are not connected to each other. So what I want to do is I want to explore the possibility of this and take a look at it from the perspective of ensuring that this communication, so the notification that's going to allow me to build that S, G entry in all of my rendezvous points that are participating in this Anycast RP set, is going to be determined based on the fact that it's going to be sent from the unique address of one device to the unique address of another. And what we'll do is we'll actually entertain that in the walkthrough in the next video. So I'll see you guys there.